Hi, everybody. So last time we talked about food chains and the fact that the arrows showed the movement of materials and energy and how they move through an ecosystem. Atoms, matter, mass, travels from organism to organism, one organism eating another, and then are recycled by decomposers, and they just continue the loop through various food chains, year after year after year, decade after decade after decade, millennia after millennia after millennia. And the atoms don't need to be replaced because they just keep cycling. Energy needs to be constantly supplied because organisms use it up as it moves through a food chain. Now, the world is not as simple as a food chain, and a mouse may go out and be eaten by a snake today, but it may be, if it's not eaten by the snake today, it might be eaten by a hawk tomorrow. And so while there is a very specific pathway that the atoms and energy actually move, that can have varied possible routes through an ecosystem. And we show that with a food web. And we're just going to very quickly kind of walk our way through how a food web works. You can see these arrows. That means that materials and energy are moving from the grass to the grasshopper. So we can look at this diagram and say, wow, does a shrew eat a grasshopper, or does a grasshopper eat a shrew? Well, we can tell very quickly from the food web that the materials and energy are within the grasshopper moving into the shrew. And that means the shrew is eating the grasshopper and not the other way around. There's some other things that we can tell very quickly from a food web. It's very easy to tell who the producers are. And it doesn't even have to be with names. They sometimes on the Regents exam, they will put letters. They'll have like A instead of grass, and B instead of grasshopper, and C instead of frog. So you can't tell what their role is at all by what you know about the organisms because they're simply letters. But looking at this, you can quickly tell that grass and shrubs are the producers. Why? The arrows move away from them only. These do not eat. There are no arrows pointing to the shrubs or the grass. And that means that they are not consumers in any way, and they never do. And so they are producers. They are trapping sunlight energy and doing photosynthesis to take carbon dioxide and water in organic material and making sugar, organic compounds, food that then the grasshopper can eat, or the mouse, right? And so on. So let's take a look at how to read this. First question, identify the producers in this food web. Well, we just did, right? They're the ones that have the arrows moving away from them. So the grass and the shrubs are the producers. 2, identify the primary consumers. Now, primary means first, and a lot of people get really confused because they think primary, that's the producers. We're talking about the primary consumers. These are the first eaters. So we're talking about the primary consumer in this chain would be a caterpillar. The primary consumer in this chain could be a grasshopper. It could be a mouse. It could be a rabbit, right? So those are all primary consumers. Let's see, secondary consumers. Okay, so we know the grass is a producer, the grasshopper is the primary consumer. That makes the frog and the shrew a secondary consumer. On this chain, the secondary consumer is also the shrew. Now, the Regents is really tricky. This is an old Regents question, and they put the frog, the mouse, the rabbit, and the shrew all roughly on the same level in the diagram, and that makes it look like they're all at the same level on a food chain, but they're not, right? The mouse and the rabbit are primary consumers because they're eating plants. The frog and the shrew are secondary consumers because they are eating grasshoppers, caterpillar, that are primary consumers. So the shrew and the frog are secondary, the mouse and the rabbit are primary consumers. What's present in the community, but not shown in this web? So what organism is in this ecosystem has to be, it cannot exist without these. Well, everything here may die. Those atoms need to get recycled. We know there's a constant source of energy from the sun going into the shrubs and the grass, but there is no constant source of atoms. There's a limited number of atoms on the planet that are going to cycle. So who's missing here that's necessary? Decomposers. The decomposers are needed to move the materials back. 5, if the frogs stop being able to reproduce initially, what will likely happen to the hawk population? Okay, so if the frogs die, there are no more frogs, what's going to happen to the snake population? They're going to die. They're not going to have food, right? Now they'll start to eat more mice, but their amount of food is going to go down, and so they're going to go down. And if their population goes down, what's going to happen to the hawks? They're going to go down. So if you see a reduction in frogs, eventually, or rather quickly, you're going to see reduction in hawks. What's going to happen to the shrew population? That's number 6. What's going to happen to the shrew population? So if the frogs disappear, what's going to happen to the grasshopper population? It's going to go up because there's less frogs eating them. And if there's more grasshoppers, what's going to happen to the shrew population? They're going to go up. And if they go up, ultimately, what impact will that have on the hawks? Their population will rebalance because there'll be another route for those atoms to have made it to them. So food webs, if they have lots of different organisms in there performing the same roles, they can be very, very stable because if there's a problem with one organism, another one can pick up that role, that niche. And so a very stable food web is one that has lots of different organisms fulfilling each role. And that is a food web.